Now, if we're going to talk about real numbers, okay, it only makes sense for us to first have a definition of real numbers. Okay, before I get started, make sure you have a pen and paper there with you so that you can write notes that you're able to refer back to. Okay, remember, mathematics is not a spectator sport. You can't just watch me and learn from observation and diffusion. Okay, you have to actually participate in the lesson. So make sure you have a pen and paper and calculator. We won't need it today, but in other lessons, just make sure you have one. All right. Now, what are real numbers? Let's get started. So real numbers are numbers whose square is non-negative. Okay, that sounds like a lot of big English. But all it means is a number squared. Who knows what it means to square a number? Let's see. Let's get some conversation going over here. Who knows what it means if I say you're squaring a number? What do you guys think? Anyone? Don't be shy, guys. Remember, you can put it in the chats as well. So squaring a number means you multiply it by itself, right? So if I say 2 squared, that means 2 times 2. Okay, I hate using 2 because it's a lot of 2s and you guys get confused with squaring and multiplying by 2. Let's say 3 squared. That's a better way to explain it. So if I say 3 squared, this means 3 times 3, which is 9. It is not 3 times 2, okay? We are squaring. That means take the number and multiply it by itself. Thank you. Who said it? Blessing. There we go. Thank you, Blessing. I didn't see your response before I started explaining. Thank you very much for saying that. So that's what it means. So a real number is a number whose square is not negative. Can you guys think of any number squared that will give you a negative answer? Is that possible? Do you guys think it's possible to square a number and get a negative answer? What do you guys think? Let me hear. Remember, don't be shy. Welcome to everyone who's joined. Blessing says, no, I don't think so. And you would be correct, Blessing. Because what happens if you square a negative number? Let's say I say to you, negative 4 all squared. That is the same as saying negative 4 multiplied by negative 4. And that gives you what in the chat? Let's hear. Let's not be shy. Thank you, Jenna. Welcome to the chat. Who else answered? Oh, Fanny, welcome to the chat. Nice. That is positive 16, guys, because if you multiply a negative by a negative, you're going to get a positive answer, 16. Okay, so far we do not know of any numbers squared that will give you a negative answer. So those are all real numbers. Okay, so we're going to be dealing with real numbers. This is what it looks like. Okay, so real numbers follow closure property, associative law, commutative law, additive identity, additive inverse for addition. Okay, and then real numbers. Okay, this is just repeating the same thing all over and over again. What I want you guys to look at is this sketch over here. And if you can screenshot, I suggest you do so. Either on your phone or your laptop. Remember, on your laptop, you press the Windows key, which look like Windows. Okay, just Windows. And then the button that says PRTSC, which means print screen. Okay, so let's look at this, guys. So this is the real number system. We've just established that real numbers are numbers whose square is positive, right? And you guys so far told me that you can't think of a number. If you square it, will give you a negative answer. So these are all my real numbers. Let's start with the main subcategories here. We have rational numbers on, I should probably use a different color, on our left, over there. And we have irrational numbers. We're going to get to the definitions just now. I just want you guys to see how this works. Okay. So, ma'am, what is proportion? Okay, Blessing, we'll get there. Okay, don't worry. Don't worry. We're going to get there. Okay, now let's see. So let's see. We start with real numbers, right? Real numbers is the main category here. And our two subcategory is our rational and irrational numbers. That's for you guys who want to put it in some sort of flow chart thing that makes sense. Okay, so real numbers can be split into rational and irrational. But within rational numbers, we have a whole bunch of other types of numbers. Let's start with integers. Okay, we're here and we have integers. And integers go into whole numbers, which then end with natural numbers. Okay, now I'm going to explain this whole number system, but I am starting from the inside going out. So that means natural numbers is our first category of the real number system. So natural numbers are the numbers starting from 1 until infinity. Also categorized as counting numbers. Counting numbers. Okay. I think that's important to remember because decimals are not part of the natural numbers category. Okay, so when I say counting numbers, I mean 1, 2, 3, 4, 5, 6, going all the way up to infinity. Infinity means as far as you can think. Okay, so those are what we will categorize as counting numbers, which are natural numbers. So these numbers lie on the right side of a number line and they are all positive. Okay, so that's why they are contained in the absolute center of my number system. Okay, afternoon. Someone is struggling with sound. Okay, I'll take care of that just now. Okay, so now let's take one step further from natural numbers. So if you take all of the natural numbers and you add the number 0, now we're taking one step out of the natural numbers into the whole numbers. So whole numbers includes all of the natural numbers, but it has one extra little bit there, which is the number 0. Okay, so whole numbers, instead of saying 1, 2, 3, 4, 5, you start from 0. So you say 0, 1, 2, 3, 4, 5. But then again, they are still positive numbers, okay? And they are still on the right-hand side of your number line. Okay, now we're taking one step further out to integers. Say, what is the difference between whole numbers and integers? Does anyone actually know what integers are? Come, let's get some people speaking here. You can press reactions and press raise hand if you would like to speak. Okay, and then I'll unmute you. Or you may put your answers in the chat. That's fine. That's up to you guys. What do you guys think? What are integers? Okay, the definition is up there. But I just want to get some interaction going in the class. What do you guys think? Anyone feeling brave enough? No one yet? Okay, that's fine. That's fine. We're still getting to know each other. So integers are whole numbers, natural numbers, but now we are including what? What's different about integers, guys? Now we are including the negative numbers. Smaller than the whole numbers. That is true, Seth. Negative numbers are indeed less than the positive ones. Okay, so integers are smaller than the whole numbers. Now, guys, we have done, ain't they rational numbers too? Yes, blessing. Just remember, I was starting from the inside, going out. So I started with the most specific category, which was natural numbers. But natural numbers fall within whole numbers, but whole numbers fall within integers, so we're going out. But you are 100% correct, Blessing. They do fall under rational numbers. Thank you, Chantal. Integers are whole numbers inclusive of the negative. So that means we're going all the way from the negative side. So -3, -2, -1, 0, 1, 2, 3. So they don't start from 0. They start from negative infinity all the way down to positive infinity. Now, I have a question for you guys. Does this include decimal numbers? So, is 1,5 an integer? What do you guys think? What do you guys think? Is 1,5 an integer? Blessing says, I doubt. I need a little bit more opinions on that. Come on, guys. Thank you, Blessing, for participating. You're getting some things going. What does everybody else think? Letitia says yes. Logan says yes. Yolanda says yes. There are 17 of you guys here. There we go. Gwena says yes. More people are participating and I love it. Okay, someone said it's not. HP. What's your name, HP? Should I refer to you as HP? Remember, guys, you can rename yourself. Okay, if you join and your name is something like iPhone, then just... Okay, HP, you are indeed correct. You are correct. Decimals are not part of integers. Okay, they are not part of integers. So these three categories that we just spoke about, natural numbers, whole numbers, integers, these three are in fact not inclusive of decimals and fractions. Okay, guys, make that note somewhere. They do not include decimals or fractions. So we're talking about counting numbers. Remember, guys, when you count, you never include the decimals, okay? You start counting 1, 2, 3, 4. That's how you count. So you need to make a note of this. These three categories, let me write it in red. Do not include decimals or fractions. Okay, I hope everyone is still with me. Yeah. All right, so let's move on. Now we get to, so where do the decimals and fractions fall under? And this is where they fall under, okay? So remember, we have covered whole numbers, natural numbers, integers. Now we are on the first of the big categories we spoke about in the beginning, which is rational numbers. Do you see in my sketch that all of the fractions and decimals are in the rational number category? So that's where decimals and fractions belong. Not all of them, Blessing, be careful. Not all of them. Do you see that there is a decimal number over there? Do you see that there's another one over there? So we are going to discuss then, when does it fall under rational and when does it fall under irrational? If someone knows, you can raise your hand and tell us. If someone is aware of what falls where, you're welcome, Blessing. We'll talk about it just now. Okay. Now, let's see. Rational numbers are numbers that can be presented as P over Q. Okay, P over Q are just variables. They're placeholders, okay? It's like saying A over B. It could be anything, okay? So they're numbers that can be represented as A over B, which means fractions, okay? So this is a fraction. All right. And an irrational number cannot be represented as a fraction or a ratio. So before I expand on rational and irrational numbers, I'm going to have a check-in now, okay? We all did a check-in earlier where we had a thumbs up. Everything that I've discussed so far, are we all good? Give me a thumbs up or a thumbs down. If you weren't here earlier, go to reactions and you either give me one of these or one of those. And if you give me one of the thumbs down, you can raise your hand or chat, put in the chat, ask me a question, and then I'll clarify for you. Okay. I've only had 3 thumbs up so far. There we go. Okay, we're getting somewhere. We're getting somewhere. Thank you, Seth. I see you all in the reactions. I haven't had a thumbs down so far. So I'm assuming we're all with me so far. Thank you, Butlali. I see you guys all in the reactions as well. Bongo Musa. Ohone. Okay. Thank you. Okay. Now, with the information we have right now, okay, I'm going to need us to fill in this table. But I'm going to need you guys to help me. So don't be shy. Don't be quiet. If you want me to unmute you, you can do this with me. And so far, I haven't had a thumbs down. So I am assuming that we all sort of understand what's going on here, right? So let's get started. Here's our example. It says complete the following table. Now, this is where we lose marks as majority of the grade 9 learners. In a test, you get this table and they say, tick all that apply, not one, all of them. Okay, so 0 is a natural number. I'm going to do 0 because it's easy. 0 is a natural number, so yes. Okay, it's also a whole number. Nope, it's not a natural number. Never mind. It's a whole number. Why is it not a natural number? I almost messed up there for 2 seconds. Why is 0 not a natural number, guys? Where do natural numbers start? Let me put it like that. Where do natural numbers start? Thank you, Blessing. Seth, they start from 1. Jenna. So 0 is not part of the natural number system. So maybe I should put a cross for no. Okay, it's going to take forever if I write no and yes. So I'm going to do this. It's not a natural number. Is it an integer? Is 0 an integer? Seth says no. Jenna says yes. Everyone else says no. Let's go back to integers, guys. Integers are the whole numbers, which can be positive, negative, or 0. So 0 is, in fact, part of the integers system. Do we understand why? Everyone who initially said no, do you understand why it is an integer? Remember, we're all here to learn, so don't be shy or ashamed or anything. Okay, so everyone who initially said it was not an integer, Blessing says yes. Thank you, Blessing. Everyone else who initially said it was not an integer, do you understand why it is? Remember, integers go from negatives. So let's say -9, -8, -7, -6. We all know what a number line looks like, right? Let me go on the side here. So it looks something like that. And we have a 0 in the middle, and 1, 2, 3, and so on and so forth. And this side is -1, -2, -3. So 0 has to be part of integers. It's right in the middle of the negative and the positive numbers. So these are integers. Okay. I hope everyone who was confused initially is now with me. So 0 is indeed an integer. Is 0 rational? 0 is not a rational number. Oh, that's interesting. Let's see. What does everyone else think? Okay, Chantal says yes. Chantal, do you care to DM me a reason if you don't want everyone else to see the reason? Why do you think 0 is a rational number? Or why do you think 0 is not a rational number? What do you guys think? No one willing to share? Come on, guys. If one person unmutes, I promise you it's going to open the floor and everyone's not going to feel shy anymore. There's a mosquito attacking me. Sorry. Okay. Blessing says it is rational. Jenna says yes. Remember, guys, 0 is over here with whole numbers, which is within the rational numbers. So 0 is, in fact, rational. You see? I feel like you guys got confused with natural numbers, rational, excuse me, because it said A over B. So let me go back and explain that for you guys. If I write the number 4 over 1, that is a fraction. Do we agree? Do we all agree that that is a fraction? Yes, it's a fraction, right? But it also means 4 divided by 1, doesn't it? This fraction also means 4 divided by 1. And what is 4 divided by 1, guys? What is 4 divided by 1? It's just 4. So do you see why all of these numbers that are inside, all of these, qualify as rational? You can rewrite any whole number as a fraction over 1. So if I say 0 over 1, what's 0 over 1? What's any number divided by 1? It's the number itself, isn't it? So then 0 divided by 1 is 0. So can I write? Yes, Chantal. Rational numbers includes all integers because you can write integers as a fraction over 1. So do you guys see now why 0 is part of the rational number system? We're learning. We're unpacking our brains a little bit here. So is 0 a rational number? I'm going back to my question. Is 0 a rational number? Hopefully we understand better now and we don't just answer, thank you, it is. Okay, if it's rational, it cannot be irrational. And finally, is it real? Is it real? Blessing says no. What does everybody else think? Let's go back and think of what real numbers are. Remember, real numbers are? Real numbers contains all of these. Okay. Real numbers is all of this. The only non-real number, let me show you. A non-real number is when you try to square root a negative number. I'm going to use a because it's a variable. That is the only time a number is non-real. If it's not a square root of a negative number, then it is real. So yes, indeed, 0 is real. Whew. Okay, let's go to square root 7. Do we all have our calculators on us? That button that's like this, and it has a little box at the bottom, and put a 7 there. Is 7 a perfect square? Let's see. Is it a natural number? After you square root 7, do you get a natural number? No. Thank you, Logan. It is indeed not natural. Is it a whole number? Whole number? No. Anyone? No. Is it an integer? You say yes. What are integers again, guys? Let's revise quickly in the chat. Anyone tell us what integers are? Quickly, quickly, quickly. Integers. Anyone? numbers less than 0. No, it's negative or positive numbers, including 0, but not decimals. When you square root 7, do you get a decimal number? If you put the square root of 7, do you get a decimal number? Yes. So can it be an integer? No. Okay. Blessing. I like the fact that you guys are participating because it means you are unraveling your minds. Now, rational is going to be a little bit tricky here. Okay, rational is going to be a little bit tricky. Do you guys think this is a rational number? Nice, Chantal. Do you want to tell us why you don't say it's a rational number? Anyone have an idea why? Okay, let's go here. I think it was Blessing who asked, when do you know when a decimal is rational and when it is irrational? Let's look here. Okay, so some special characteristics of rational numbers. Okay, so every rational numbers is either a terminating decimal or a repeating or recurring decimal. Okay, some of your teachers may have called it a recurring decimal. Okay, what does terminating means? It means it ends at some point, right? 2,5 is a terminating decimal. Okay, recurring means it has the same decimal over and over. For instance, if I say 0,666, nope, I should have used a different number. I have a very cute sense of humor. You guys will get to know me. 0,22222, and it's 2222222 forever. That is a recurring decimal. So if your decimal is one of these, then it is rational. Okay, but let's look at the other side. If your decimal is non-terminating and non-repeating, then it is now, in fact, a irrational number. Let's look at examples. Non-terminating means 0,57239 It's just a bunch of random numbers. You get it? Can you guys predict what's going to come after the 4? Do you guys think you can predict what's going to come after the 4? No, because it is non-repeating. Okay, so therefore, this qualifies as an irrational number. It is not rational. Remember, rational means it is ordered. Okay, it has a pattern. But this is irrational. It's just a bunch of random numbers. There could be anything after that 4, right? It could be a 2, it could be a 5, it could be a 9. We have no idea. But if I have a number like this, 2, 2, 2, 2, 2, or even 0,15151511, what's going to come after that 1? What do you guys think is coming after that 1? A 5, because that is a repeating decimal. So can you guys tell the difference now between when a decimal is rational and when it is irrational? What do you guys think? Thumbs up, thumbs down. Do we understand the difference between a rational decimal and an irrational decimal? Okay, I see 2 thumbs up out of 17 people, so I expect more thumbs up than that. There we go. 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 I love it. Okay. That is beautiful. So now that we know how to distinguish between the two, is the square root of 7 repeating? Is the square root of 7 a repeating decimal? No. So it is therefore what? Is it rational or is it irrational? Thank you. Oh, you guys are so good at this. Okay, Now, we have established that it's irrational, but irrational numbers are still real numbers. So it is still, in fact, real. Okay, I hope I didn't lose anyone there. Remember, the only time we have a non-real number is a square root of a negative. So it might be irrational, but it's still real. Okay, let's go to the next one. What is that little symbol over there? What does this little guy mean? Do we know? Does anyone know? Pi. Beautiful. Okay, it's spelled P-I, but you guys get it. Okay. Do we know how to find pi on our calculators? Ooh, I don't think I brought my calculator here. Yeah, I think you press shift. Okay. And then it's the button that says times 10x, something like that. Something like that on your calculator. It should give you the pi on your screen. And then you press equals. And then it gives you some sort of number. Has anyone found it yet? Let me see if I can find it. Let me see if I can find it. Anyone found pi yet for us? Come on, guys. We must all participate. Pi. There we go. Okay. I'm going to tell you guys what I found when I pressed pi. Okay. I found 3, comma, 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, and there's more numbers after this. Do we have any idea what's coming after that 5? Do we have any clue what's coming after that 5? No, Seth. So that makes it a what type of number? Rational or irrational? Butlali says yes. Butlali, how do you know what comes after that? Thank you, Seth. We are working. It is therefore irrational. Thanks, Blessing, Jenna, Linomta. Yes, it is irrational because unless you took out your calculator, you would have no idea what's going to come after that 5, right? It could be anything. So if it's irrational, do you agree that it cannot be rational? It cannot be an integer. It is definitely not a whole number, and it is not a natural number. Is it real though? There we go. Seth is on top of the game. I love it. Beautiful, guys. Nice. Okay, I want us to do one more. One more because I want to move on. Look at J. Nope, J and K. We're doing J and L. Sorry, 3 more. J, K, and L. Those are very important ones to do. Let's start with J. I want to talk about this dot on top of the 9. Does anyone know what that means? It says 1,9 and there's a little koliki there on top. Does anyone know what that koliki at the top means? No, Blessing. Okay, thanks for responding. No, nice try, Seth, but it's not an exponent. It is recurring. Does that word sound familiar? This means recurring. Yes, Yolanda. Yes. So that means this is actually, there we go. This is actually 1, comma 9, 9, 9, 9, 9. But they can't write all those 9, right? So they just draw this little dot at the top to say it's 1, comma 9 forever. So it's a bunch of 9s after that. So yes, thank you, Linamta. You have started us off nicely. It is indeed rational. Where am I? There. It is rational. Okay, so if it's rational, it cannot be irrational. Now, is this a natural number? We're going back to remembering now. Is this a natural number? No, Blessing, because it is a decimal. It is a whole. Is it a whole number? Is it whole? If it's not natural, can it be whole? No. Is it an integer? No. But is it real? Yes. We're getting the hang of this. We're getting the hang of this. Okay, let's look at the next one. We have square root of negative 16. Can you have a square root of a negative number. No. So this is in fact our first case of what? This is our first case of, let's see if we're going to use the right word, non-real. Beautiful. Oh, you guys are beautiful. So if it's non-real, it is definitely not natural. I promise you it's not whole. It's not an integer. It is irrational. It's none of these. Okay. Because remember, all of these fall under real. So if it's non-real, it can't be any of the, we have no idea what it is. It's a non-existent number. Okay. Now, the last one is going to trick us a little bit. That's the cube root. See that 3? That's not a square root. It's a cube root of -8. What is the cube root of -8? Does anyone know? Can we find the cube root of -8? Let me start there. Is it possible to find the cube root of -8? Nice. Bohlale. Yeah, I have a feeling you're not the only one who doesn't know that. Okay. Remember, guys, cube root means what do I multiply by itself 3 times to get my answer over here? 3 times, not twice, right? So look at here. If you say -2 times -2 times -2, that's what cubing means, right? Now, a negative and a negative give you a what? Let's see if we remember. 2 negatives, if you multiply them, give you a, thank you, a positive, right? And then you multiply another negative. Now you're sitting on a what? You had a positive, but you went and multiplied another negative. So here is a positive, right? So you're taking this positive times this negative. Nice. So my answer is going to be negative. What's 2 times 2 times 2? What do we say? 2 times 2 times 2. That is 8. So can we, in fact, cube root a negative number? Yes, we can. Okay. So the answer of cube root of -8 is -2. So remember, if you answer such tables, please simplify where you can. So if you see cube root of -8, you write for yourself, this is the same as -2. Now let's answer, is -2 natural? This is our last one that we're doing. Is -2 natural? Nope. Is it a whole number? Nope. Is it an integer? Yes. Is it rational? Indeed it is. Remember, if it's an integer, it is rational. Okay, so think about it like this. All of these 3 fall under rational. Okay, is it irrational? No. If it's rational, it cannot be irrational. And finally, is it real? Our last category. Yes, thank you, blessing. Woo, thumbs up, thumbs down, and then we're going to our brain break. Our brains need a break. Thumbs up, thumbs down. Do we understand the last 3 that we did? Yes, I see a lot of thumbs up. We're getting more confident now. I love it. I love it. Okay, let's go to our brain break. Okay, does anyone want to unmute and talk to me? Anyone, guys? It's not a math sum, I promise you. It is just a brain break. Anyone? Go to reactions and press raise hand if you'd like to talk to me. No? Okay, that's fine. Maybe in our next lesson, we'll have a little bit more confidence. But would you rather, guys, fight one horse-sized duck, so a massive duck, or 100 duck-sized horses? So would you rather fight one really big duck or 100 really small horses? What do you guys think? Let's hear in the chat. Someone wants to unmute, you still can. Just raise your hand and I'll unmute you. What do you guys think? HP's like, I'll take the horses. I'll take the mini horses. How are you going to fight a massive duck? Oh my goodness. Oh my god. There we go. We have our first hand. Boo, 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 boo. Never mind. She vanished. Chantal, can you unmute?
Ma'am, I would rather take 100 ducks.
No, it's 100 duck-sized horses. So they are
Yes,
horses.
ma'am. Yeah.
100. Do you know how many that is? That's a lot.
Ma'am, don't be small.
They're not that small, guys. Ducks are not that tiny.
Ah,
Okay, Chantal, thanks for being the first one to break the ice. Boo, 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 boo. Let me
thank
just
you,
shut up.
ma'am.
Okay. Wow, I can't believe. No, HP, there are a lot. 100 is a lot. Okay, it's a lot. Let's see the second one. Would you rather have your ringtone be someone screaming or someone crying? Like imagine you're sitting in school and your phone rings. Would you rather have the screaming? Screaming is a lot. Ah, what guys? Ah, why not crying? Ah. Thank you, Yolanda. What if it's a silent crier, guys? What if it's a, did you guys want someone to go and like everyone who's sitting next to you is gonna get a fright. We're all gonna jump and be like, what? What just happened? Oh, you don't like the sound of crying. Okay. Okay. Yeah, I'd also rather take crying. I'm not gonna lie. I can't see myself on the phone while sitting and my phone rings and someone screams. Guys, I'm such a scaredy cat that I will probably also freak out and forget it was my own phone that is ringing. Like when people start running, we all run. Let's go. Let's go. Let's go. Bushal is laughing. Wow. Hectic. Oh, that's a valid reason, Lenomta. Okay, and the last one, would you rather only take 4-hour baths or only take cold showers, like for the rest of your life? What do you prefer? What do you guys think? 4-hour baths. Letitia's hand is up, and then Letitia put it down. Ah, Letitia. There we go. It's back up. We're back on. There we go, Letitia.
I would choose 4-hour baths.
You're gonna come out there with wrinkled skin. Do you know that?
Yeah, but I don't like cold water.
Yo, Letitia, guys, me, I'd rather take the cold shower. I don't want to lie. Mm-mm. Guys, imagine you have homework and you must shower for, bath for 4 hours is a very long time. It is a very long time. I would rather take a cold shower. I'm sorry. Okay. That was our brain break. Okay, let's have a stretch. And then we're going to do 1 or 2 more questions and call it a day. Okay, major shout out to everyone who was brave enough to raise their hands. So this is another summary for us, okay? For people who would want to visualize it nicely, but this summary has something else that's very important, which is our symbols. Do you see the symbols, guys? Okay, so your real numbers have a symbol. In maths, we don't like to use too much words, right? I don't want to speak for a long time. So if I write this symbol, okay, like it's a double-walled R, then you know I'm talking about real numbers, okay? And then we go to rational. We cannot use R again because we just used it for real. Okay, so for rational, we use a Q. Okay, it's also sort of double-walled, okay, like so. And then for irrational, it's actually really interesting. We use a similar sign. We do the Q, but we put a little koleki there. Okay, it's like a little not Q. Okay, and then we have integers, which is the Z. Okay. Then we have whole numbers. Okay, there are two symbols that I've seen for whole numbers, and I'm going to give you both. So in the olden days, we used to use this. I say the olden days like I'm so old. Oh my gosh. So old. We used to use this. Whoever's drawing on my screen. Okay, and a 0 at the bottom. Okay, now the reason we did that is because for natural, Zeth is laughing at so old. For natural, it is the n, right? But remember, whole numbers are all the natural numbers plus 0. So we used to use the same symbol, but just put a 0 at the bottom there. But now recently, I saw the new textbook use a W for whole numbers. I just don't know where the double wall goes. Does it go there? I don't know. Okay, so if your textbook has a W instead of an N with a 0 at the bottom, that's still whole numbers. Right. Do you guys want to take a screenshot? Sorry, I moved on too quickly. Screenshotters, screenshot quickly, quickly, quickly. Okay, we should be done. Some of you guys' profile pictures are very cute dogs, and I love it. I'm here for it. Okay, now we have one more table to fill in. We're just going to fill in as much as we can, seeing as we are about 10 minutes out from the lesson. Okay, so you guys need to write whether this is true or not for each number. Okay, so the first thing says the sum of two numbers is a number of the same kind. If I add two natural numbers, will my answer be a natural number? What do you guys think? If I add two natural numbers, will my answer be a natural numbers? Beautiful. Yes, that would be a yes. And if I add two whole numbers, will my answer be a whole numbers? A whole number? Oof, English is chowing. Guys, this is why I teach math. The English is not my thing. This is in fact also true. Right? If I add two integers, will my answer be an integer? Yes. But now it gets a little bit tricky. When I add two rational numbers, will my answer be a rational number? What do you guys think? I see some no's, a yes, a yes. It will, in fact, still be a rational number. So think about this, right? Terminating decimal, 1,5 plus 2,5. What's that going to give us? What's that going to give us, guys? Those are two rational numbers. It's a 4. Is 4 rational? Yes. Okay, so anytime you're not sure, just do a little trial on the side for yourself, and then you'll see. Okay, let's go to the second part. The sum of two numbers is always bigger than the two numbers. Okay, what this means is if I say 1 plus 2, the answer must always be bigger than 1 or 2, which is true in this case, right? 3 is bigger than 1 and 3 is bigger than 2. Will that always happen for natural numbers, do you think? Levi, what do you mean no? Or were you answering the natural numbers thing? Will that always happen for natural numbers, guys? Remember, natural numbers go from 1 up to infinity. Yes, it will. Okay, if you add two natural numbers, the answer will always be bigger than the other two. So this is yes. Will that always happen for whole numbers? Now we have to put a bit of thought into this. So will that always happen for whole numbers? You guys are saying yes. If I say 2 plus 0 equals 2. 0 is a whole number, isn't it? 0 is a whole number, right? So I added 2 plus 0. But my answer is 2. 2 is greater than 0. But is 2 greater than 2? No, they're equal. So will this always happen for whole numbers? What are we saying? Okay, I only see one answer, and that is a no. Thank you. Will that always happen for integers? Integers are even more complicated because they're negative. Beautiful. No. If you're not sure, guys, go do trials. And will that always happen for rational numbers? No. Whew. Okay, guys, that was our first lesson. How's everybody feeling